Hey everyone, Ned here. I made another thing and I thought I'd show you guys what I've made, see what you guys think. Made an OSD for a quadcopter and I wanted one that was nice and easy, fully featured and worked with the KISS flight controller. So I've actually really locked in a lot of things where it kind of should be used, and it's for the way I like it. But I'll just give you a quick little overview. So we have a OSD over here that I made, which is strongly based on the Minim OSD. It's actually code compatible, so if you don't like my code, you can just run Minim OSD code on it and Bob's your uncle. There is the TBS Unify Pro 5.8 high voltage one, which runs SmartAudio 2.0, which I actually support, so that'll be pretty cool when you see that. And just a display that displays what's going on. Got it all running off a power supply at the moment, so let me just turn everything on. So there it is. There's some LEDs as well, the old WS2812B strip LEDs, control those as well. Quick little overview of the OSD. As you can see, there's no video coming in because I'll just complicate everything, but down the bottom left we've got current, which comes from the KISS, voltage, which can come from the KISS or on-screen or on-board voltage measurement. It can even come from the KISS ESCs if you've got the KISS ESCs plugged in. Then milliamp usage from the KISS flight controller as well. RSSI, a little timer over here that counts how long you've been armed for, and over there, again KISS related, is the ESC temperature, or the hottest ESC temperature anyway. And as you can see underneath it actually says in range pit mode active. So the TBS video transmitter has a thing called pit mode, and the idea is when you turn on your video transmitter, it goes into really low power mode so that you don't mess with everybody else flying, make sure everything's okay, and then you can turn it back off and go flying in full power mode. And on this OSD, it's actually controlled automatically. As soon as you arm the quadcopter, you'll see that the timer will start counting, and it'll also get out of pit mode and it'll go into full power mode. So we'll just do that. So when we arm the quadcopter, that line will disappear, and as you can see, it will display the frequency we're transmitting on, race band, channel 2, and 25 milliwatts, and the timer's running because the quadcopter's armed. Now, to make any changes to any of the settings of the OSD, which there are a number, we'll have to go into the menu, and to get into the menu we first have to disarm the quadcopter, and then we should be able to get into the menu. So using the right stick or your roll and pitch stick on your transmitter, you can navigate the whole menu. So you've up and down, left is clear or back, and right is okay, save, next, whatever. So we have a menu with a number of options. First option is RGB LED, then we have RSSI, voltage, VTX settings, OSD options, load defaults, and close menu. We'll start off with the RGB LED. There's a number of presets we can go into, or you can go by RC channel, or we can pick a random color, or we can control it via the VTX. So if you just go into the preset colors, there's just a number of colors we can pick from. Pretty simple. Pick the color you want, and you press OK to save. It will save the data, so next time you turn it on, you get your same color back. We can go into RC channel, so it will set the color based on one of the auxiliary inputs of your transmitter, which I currently don't actually have one plugged in, so they're all the same. But if you set it to an auxiliary input, you can connect it to a slider on your transmitter or make your Tyrannus or whatever you use, program it to output different colors for different states, whether it's different flight modes, battery voltages, anything you like really. Menu automatically closes after 15 seconds, so we'll go back in. We can also just pick a random color, set your red value to whatever you like, save that, modify green, so take a bit of green out, save that. You can also set your brightness, so it's currently set to 10%, so that'll go reasonably bright. Just a bit bad for the video, so we'll turn it back down again. Actually, I can also show you if you do change it, if you forget, if you don't save it and you just go back, it will just disregard all your changes, and life's good. VTX is probably my favorite, VTX frequency color. So now the color changes depending on what frequency your video transmitter is transmitting on. So if we go to the VTX settings and we change the channel, which is channel 2 on race band, if we change it to channel 1, color changes to more red. Go to channel 3, it's green. Channel 4, turquoisey. Blue for channel 5. That's actually more blue. And back around, so all of the channels will have a distinctly different color. So if you're racing with friends, all have the same feature enabled, then you just have to look out and make sure that no one's on the same color, and you can safely race together. So that'll obviously only work with the TBS module, which has SmartAudio, which is a serial protocol that runs over the audio port, over the audio channel, to be able to program the channels and frequencies and transmitting power. So I'll show you some more of those features. So we can also select our band, for example. So if you want to go to band A, you can go to band A. Also the frequency obviously changes again. Band B, E, F, and race band. So all the usual suspects are all there. Set your channel, again much the same as before. Output power, so we can have 25 milliwatt, 200, 500 and 800. Nice and easy to program right from the OSD. Don't have to fiddle around with the button and looking at flash codes of LEDs. It's just there. PID mode, which I talked about earlier, so we can have it completely off. So whatever happens, your video, as soon as you boot up, the OSD boots up and makes sure that your video transmitter is transmitting. That's not in PID mode. Everything's at full power, your program power, and everything's good. You can have it VTX controlled, meaning that the OSD doesn't do anything. If you enable PID mode by holding the button down while you boot it up, it stays in PID mode. If you boot it up normally, it goes normally, and it doesn't interfere whatsoever. There is in-band and out-of-band PID modes, and in-band means that it transmits on whatever frequency you're on. So if you're on race band 4, you go into PID mode, in-band PID mode, then it'll transmit on race band 4. You can have out of range PID mode, which means that it'll go to a predefined frequency. I forgot what it is, 55, 60 or something like that. And that way you won't interfere with anybody else when you turn on your quadcopter, just to be sure. So you can also have it in auto mode and in on. So if you turn it on, then it just turns on, it's in PID mode, and it won't go out until you turn it off in the menu. If you set it to auto, it will, when it boots up, it'll go into PID mode, and as soon as you arm your quadcopter, it'll automatically turn off PID mode, go to your program transmitting power, and you're ready to fly. The voltage, there's a number of sources, so we can have the onboard ADC. The flight controller has a voltage measurement, and the ESCs, the KISS ESCs also have a voltage measurement. You can pick which one you like. Generally set it to flight controller, and then once you click OK there's also a calibration, so if you find it slightly out, you can modify it by plus or minus 10%, or 9.9% I believe. That's the same for whether you use the ESC, flight controller, or the onboard measurement. The calibration numbers are different for each one, so they stay. So if you calibrate this to plus 3% and you go to the flight controller, that's still 0%. There's also ampere current measurement adjustment, so you can calibrate that. If you find that the KISS ESC isn't quite accurate enough, you can fine tune it there. Same as the milliamps, so they're separate just in case for some reason one of them is out and the other one isn't quite as far out for some reason. Then RSSI, again there's two sources. There's an RC channel, which is what I like to use. The Tyrannus you can actually get the Tyrannus to feed the RSSI value back into a spare channel and send it back to the transmitter, so you don't need to have another cable connected from your receiver to your flight controller or your OSD. It all just comes via the S-Bus and no extra cables. It's fantastic. I like using it that way. But there is an analog read input as well on the OSD. You just connect in your RSSI and it'll filter it for you and it'll read it, and you can use that. Then there's also calibration that you can do. So it's currently not calibrated, but what you do is basically you turn it on, you leave your transmitter about a meter away from your receiver, so that's about as good a signal as you're going to get, and then you press OK on the calibration and that's what it'll save, and it'll calibrate it to that. On-screen options, OSD options. Not everybody wants to display all of these things, so there are a number of things you can disable. So you can start off with the timer, turn that on and off. Maybe you don't want the RSSI because you've got an audio alarm set up. You don't need to know the VTX frequency, which by the way, if you don't use the VTX, the TBS Unify Pro, then it simply just won't display that information. The menu that sets up the video transmitter also won't be available, so it just pretend it won't actually be there. So you can go through and turn off each individual thing. So if all you want is, say, voltage measurement, then there you go, you just have voltage. Obviously amps are probably quite important, so a nice minimalistic view, as minimalistic as you want. You can modify it to your heart's content. You can load defaults if everything turns to rubbish and doesn't work, and it's just a close menu. There's also a few other screens, so there's a quick overview screen for the video transmitter settings, just reading the sensor outputs from the KISS ESC that's not plugged in, and software revision numbers, etc. So that's a quick little overview. The software appears to be working reasonably well. I need to go and make a bunch of changes to the hardware so that we can actually fit it on smaller quadcopters, and it will actually be able to support 130 amps because the current version doesn't. It will get a little bit smaller than what the current one is, and there's a few other little tricks that are going on that will make it pretty great if you ask me. Let me know what you think. See if there's anything you like, you don't like, maybe some changes you'd like to see. That's about it really. thanks for sticking with me for this 15-minute video, and see you later.